Hi guys, welcome back. Welcome to day 2 of Law of Sines. So day 2 today, what we're going to do is solve for a triangle when you're given two sides and an angle. So a little bit different. If we look back at what we talked about yesterday, when we were given a triangle, it was how can you find a measurement when you're given two angles and one side? So what we did was the same process over and over again in this example. Is we labeled what we have. What are we looking for? Again, I always suggest to find the largest angle and or largest side first. That helps to get you into the ambiguous case out of it, so you're not going to be in this spiral of finding all these triangles that possibly could exist. Okay? Again, law of sines is up here at the very top, and what it looks like. Zoom in here. It's sine A over side A equals sine of angle B over side B equals sine of angle C over side C. You don't have to use all three of those fractions, but you pick the two you want and then you solve. Because they are proportional, equal, you can cross multiply to solve, which is the best way to solve these, okay? So again, this is the last day of what we're focusing on, just law of sines, and then tomorrow we're going to bring in law of cosines. So let's do one. So again, we've already done one right here, example 1. Okay, right here, example 1. When we were given two angles and one side. And we found angle A by subtracting from 180. And then we found angle C, or side C first, because angle C was the biggest, by law of sines. And then had to find side A by also using law of sines. You cannot use Pythagorean theorem here because this is not a right triangle. So law of sines, day 2. Let's see what we have going on here. Same essential question. How can you find the side and angle measurements of a non-right triangle? Well, right now we know law of sines. That's pretty much all we know, but we're going to get to further. So let's do some here. So again, what we're going to do today is we're going to solve for this entire triangle. I know it says just to find the angle measurement, but I think it'd be better to solve for the full triangle. So when I look at this here, they give me angle A. And they say find angle A. Great. So let's first label my sides. I like to label going back to geometry. So if that's angle B, this is side B. If that's angle A, this is side A. And if that's angle C, this is side C. Okay? So again, even though the directions say something different, I want to find the measurement of angle A, the measurement of angle B, and the measurement of angle C. I also want to find side A, side B, and side C. So let's see what they gave us. Well, they gave us that angle B was 116. Beautiful. So I know the other two angles have to be acute because a triangle has to equal 180. Then they gave me side A was 12. And then they gave me side B was 23. Beautiful. Remember, in order to do law of sines, you have to have a pair. An angle and side that have the same measurement. So right now I have angle B and side B. Because I have two letters that are the same, I can use law of sines. If I don't, then I can't use law of sines, and that would tomorrow will be law of cosines. So the only thing we can do is find angle A first, because we know nothing about our C's. Nothing about our C's, so we have to use what we know. So we got to find angle A first. So let's do it. Let's get started. So I have sine of 116 over B, 23, equals sine, I don't know A, angle A, but I know side A is 12. Okay? I also know that none of my side lengths should be bigger than 23 because my longest side length is always across from my longest angle measurement. So just like yesterday, what I'm going to do is I'm going to cross multiply to solve. So I get 12 times sine of 116 equals 23, not 32. 23 sine A. And just like before, I divided by what I didn't need. So here I'm going to divide by 23. A lot of people will try to divide by the sine, and you can't do that. That sine and that A are attached. They're kind of like multiplied together if you want to think of it like that. So I end up with, I'm going to flip this, sine of angle A equals 12 times sine a 1/16 over 23. Great. Now I have to get rid of that sign. Well, I have to think back to last week when I was doing trig. And when I was finding an angle measurement, I always did the inverse function to cancel out. So I'm going to multiply by the sine inverse. I have to do it to both sides, just like I'm solving an equation. So when I do that, I get A equals the sine inverse of that entire fraction. So this is where it gets a little bit confusing on your calculator. So hopefully that makes sense how I got angle A left on one side and everything else on the other. And how do I do this? How do I not mess this up in the calculator? Well, there's a couple different ways you can do it. I suggest just breaking it down in parts and not trying to do everything at one time. So what I like to do on my calculators, I like to do 12 times sine of 1/16, enter. Again, make sure your calculator is in degrees, not radians. And then I like to divide that by 23 and enter. And right now I'm at 0.468936. I take as much of that fraction as possible. And then I do the sine inverse of that fraction. So again, I do the numerator, okay? Then I add on my denominator. And then I do my sine inverse. So I do numerator, enter, divide by denominator, enter, sine inverse, and I end up with 27.96. But again, we're trying to find angle measurement here. So I'm going to round that to approximately 28 degrees. So I'm going to go up to my little triangle here that I was solving for, and angle A is 28. Okay, great. Almost done. Now I gotta find C. Well, I know two angles of a triangle, so I'm gonna do 180 minus 1/16 minus 28, and that gives me 36. So my angle C then has to be 36. Okay? So again, I don't like that 28. I'm gonna rewrite it. So this is 28A. Angle B is 1/16. Angle C is 36. Side A is 12. Side B is 23, and the only thing I have left to find is side C, okay? Again, I like to use what was given to me. So this was given and this was given, so I always refer back to those items that were given as my first fraction to go to. Why? Because I know I didn't round them, I know I didn't make a mistake, I know those were always the answers. So now I'm going to find side C. And how I do this is I'm going to do it exactly like I did on yesterday's work, okay? So what that looks like is I'm going to find side C to finish off my triangle. So I'm going to get the sine of 1/16 over 23, because that was angle B was 1/16, right? And side B was 23. I'm then going to do my angle measurement of C. Well, C we found was 36. So sine of 36 over my C. So I set up my ratios. Again, this right here is always my given. That's what I like to do because I know I didn't round it. And then what am I looking for? Again, just a lot of repeating over and over again with law of sines. So I get C times sine of 1/16 equals 23 times sine of 36. From here, I'm trying to get C by itself. So I'm going to divide by sine 1/16 because it's multiplied together. So I'm going to do the opposite. Those cancel. So I get C equals 23 times sine 36 over sine 1/16. And then I get C's approximately. Again, I do the numerator first, so I do 23 times sine 36, enter. Divide by sine 1/16. Again, I like to separate it up. And I get 15.04. So I'm going to do 15 is perfectly fine. So then I'm going to go over here. And for side C, I'm going to type in 15. And I'm done. I have solved for the entire triangle. So now I should know how to solve for a triangle when given two angles and a side, and when I'm given an angle and two sides. Okay? Come back tomorrow to learn law of cosines. Have a fantastic day. If you have any questions, log on to Zoom. Thanks, guys.